Hey, thanks, Isha, for the introduction. And it's such a pleasure to be here and to share with you the story about how we can make large language model or generative AI working for enterprise and governments through the integration with knowledge graph. Cool. I think because I'm the person standing in front of you, between you and the lunch next door, I'll make sure this session is going to be very interesting and very exciting. But indeed, I think, why the font is so small? Anyway, yeah, indeed, I think as a data practitioner, our life is full of excitement, right? If you still remember in the last 9 months, like around November last year, what happened? The announcement of ChatGPT, right? All of a sudden, it came to the headlines of all the new medias, newspapers, magazines, right? People got excited about it, and people got it from different angles. And also people sense the smell of the fortune. And some people started worried, concerned, right? And some people took advantage of ChatGPT, and the others fought back. Of course, some other people make a joke of it, right? ChatGPT is something to stay or to go away, something like that. But regardless, ChatGPT, large language model, generative AI is definitely a phenomenal thing globally. That's why we saw the Time magazine in February, at least this year, the issue had its cover on the cover. So I don't know how many of you, I guess, maybe have been using ChatGPT since then, or GPT or ChatGPT or whatever thing. Yeah? You do? Okay. So some of the jargon, some of the terminologies, GPT stands for Generative Pre-trained Transformer Language Model. Not that sexy, right? And also ChatGPT is basically it's a way of the machine learning, the AI model based on transformer architecture, with a massive amount of source data trained and tuned. Eventually got this point. At the moment, the ChatGPT 3, 3.5, 4, and you see more and more are released. Its knowledge is as new as September 2021. And also heard of a large language model. So generative AI basically has different aspects, different use applications. A text is one of them. It's a so-called large language model. It's just the generative AI for text. Okay. You have also generative AI for video, for images, for all other stuff. And what happened since then? Of course, there are always different angles by people. How I tricked ChatGPT into telling me lies. It's dumber than you thought. More critics, dark side, downfall of human beings' capability of doing certain things. And some people said ChatGPT, large language model is like a parrot, right? 75 or 76, more or less, like a parrot. Okay, my view, it is very revolutionary, has shown its very powerful capabilities of understanding, generating, and summarizing the text information stored in text. But by itself, generative AI cannot solve the business problem because of the issues. It has limited knowledge. Remember, it only has the knowledge up to September 2021, right? It has limited explainability. People are still trying to figure out how came this language understanding or generation capability came into place. Because whole model is a massive model. It's like a black box. You guys, if you do your data science, you know how machine learning model works, right? It also has a limited ability to understand the context. Basically, all the knowledge came from is all from the public space, from the web, from the documents, from other places. If we really want to apply this to an enterprise or government, we need it to be deterministic, to be specific, and also need to be reliable. That's why we believe by combining a knowledge graph, which has a predetermined knowledge about enterprise, about government, in certain domain, with the large language model or generative AI, should be able to make it more reliable and suitable for mission-critical use cases, make it more explainable, and make it more contextual and appropriate. Okay, let me explain how. Oh, I apologize for this because I produced this on a Mac laptop. Now it's on Windows. That's why you know that always a competition. They don't like each other. I hope this can work. Okay. If we just use ChatGPT or any large language model, that's where we get, right? The pointer is here. Here. Oh, okay, it's too bright. Anyway, we send a question to the large language model. It gives us answer based on its understanding of the context or what's the meaning of the question, based on the massive data source trend from the internet, from the public space, which are usually, and also because it's the limitation of the up-to-date knowledge, right? It's not up-to-date. It can't be explained very well, and it's actually not controllable. We don't know exactly like how the answers are given. But if we combine the question with some context, the context about domain, what this person is asking, which domain is from medical, from finance, from telco, so on and so forth. And what's the user profile, the access level, the classification of the person to the information, what could be the sample output, what do you expect the answer to be like, access control, chat history, so on and so forth, right? We combine the context with a question to form this so-called prompt. Yeah, I will definitely share this deck with you afterwards. This just looks disappointing. We combine everything as called a prompt, send it to large language model, and ask it to give us the answer, which should be relevant, up-to-date, and controllable, explainable. Let's have a look at an example. So for example, if I ask ChatGPT 3, GPT-3, GPT 3.5, depends on which version you use. Like when Neo4j version 5.5 was released, it was actually released like early this year. But remember, ChatGPT 3 only has the knowledge up to September of 2021. If you use version 3, it will make up something for you. But it sounds like it's very affirmative. If you use ChatGPT 3.5 and onwards, it will tell you, yeah, my knowledge is just up to this time. There might be new releases coming, so you can check the website of Neo4j, so on and so forth. But regardless, to overcome this limitation, we could provide a context, like a Neo4j version 0.5 was released in on a particular date, and the retrieval message, which is actually the question, all of the three instructions answer the question as truthfully as possible using the provided context, blah, blah, blah. And the answer is in the format of certain layout, even in the XML, HTML, everything is possible. With context, with the question itself, it will give the answer. Very reliable. It's fact-based as well. So that is the idea, right? And if you got some bit of practice into this large language model, you might understand this is something the so-called in-context learning capability of the LLM. This is one examples of in-context learning for facts. We could also do in-context learning with examples. Let's say we provide some examples, like when was the movie The Matrix released? Then give some examples, like a query language, SQL, even Python code. In this case, I'm giving the Cypher, which is a query language for graph database. The question, the example query, and so on and so forth. This is the few short learning as a context to feed into the large language model. Then users start to ask real questions, like when was Tom Hanks born? You'll try to see which ones are most likely and most similar can be used to generate a cipher, a query. The query is executed against the database to get results to the user. So far so good? Yeah. This is the in-context learning with examples, right? We generate some actual queries, based on the natural language question asked, and get the results from a place. We know where it's from, we know where it's based, because we see the query. Yeah? We see the query, we see the results, we see the answer. Make it more explainable. So this is so-called, of course, there are different patterns of integrating large language model with knowledge graph to provide better solutions, but one of them is called retrieval augmented generation. So here's how it works at the back end. So user asks a question, then we prepare a prompt. The prompt is sent to the embedding in the large language model API to produce the embedding. You guys, if you're data scientists, you know what embeddings are, right? Then the embedding is then sent to the knowledge graph to return the most relevant content from the knowledge graph. And then the context or content is combined with a question to be the prompt, sent to the large language model to generate answer. That's why so-called retrieval, is this part, left part, augmented generation the right hand part. Okay, then the question is, what is the best way to get most relevant content based on the question, right? If a language model can help us with the summarizing or generation of the answers, the only thing left for us is to find out the most relevant content to prepare for the context. Okay, here's one of the ways, is to use something called semantic or similarity search based on the embeddings of the question compared to the embeddings of the contents in your knowledge graph, using something like similarity, cosine similarity algorithm. For example, what is text embedding? This is a question. The question is sent to the, for example, large language model to produce the embedding of the question. Then the embedding is compared to all of the embeddings of the contents stored in the knowledge graph, and to see which content, which text has the most similar score using cosine similarity. Then we return the list of it's like a fuzzy mesh, yeah? The only major difference is fuzzy mesh is based on the text, based on the different model, like frequency of the word, so on and so forth. This is based on the semantics, the meaning in the model. Here's an example. What is text embedding? It can be represented or translated or transformed into something like this one. The vector. Vector is a data type, right? Data structure. It's a list of floats. For large language, like for GPT, it produced 1,536 dimensions, or floats to represent any text, any piece of text. The translation process called embedding. Probably there's different. If you are familiar in this space, there's a word-to-vec. There's a different bird has different. Transformer has different way of generating embeddings, so on and so forth. Then let's also consider the two answers here. Answer one, embedding is a machine learning process, blah, blah, blah. Answer two, embedding is to implant an idea or feeling so that it becomes ingrained within a particular context. Remember the question. The question is, what is text embedding? So when we calculate the similarity between the two answers against the question, right? Apparently the first one is more close, right? Because it talks about machine learning. The context is machine learning, and also talks about text, so on and so forth. That's why it has a higher score of the similarity than the second one, right? So it's selected as a context to be fed into the large language model to produce the answers. So in the past, if we use the graph database to store unstructured data like text, we go through a whole bunch of natural language processing steps, right? To do like entity extraction, relationship extraction. For example, for this sentence, in December, blah, blah, that's December 1903, that's a date. Then the organization name, the person name, and the event name, so on and so forth, right? We store this like this as a graph, like basically the entity, relationship, another entity, right? That's a graph. That's a very, very straightforward, intuitive way of representing data, the real world, from the real world events or things. It's graph. Now, with the embedding, with large language model, we can also store the embeddings of the text, like the event, name, sentence, paragraph, even the whole document, as the value of the property of the thing. The thing has a text, which is an event or news title. It also has an embedding, right, as property values in the graph database. And the benefit of doing that, for example, here is example graph model for the academic papers. We have a paper has abstract. And the paper also has authors, has title, abstract has its text, abstract also has the embedding stored as a property value, right? By doing this, we can do like semantic search of the paper based on the meaning of what we actually asked, right? For example, we can ask something rather than not just using the keyword-based search or fuzzy match. It's way beyond that, more powerful than that. Oh God. And because in the embeddings or vectors are stored in the knowledge graph, right? The next step, if we have a large data set, we have a large amount of embeddings to look for, we need to create an index. As a graph database, Neo4j now has a vector index. You can just create and you can search. Oh. Okay, I have to go back. If you compare this exercise with you storing your embeddings into a vector DB alone, the benefits are you can not only search based on the similarity of the question, the contents, and to get to the abstract, which abstract is exactly about. You can also traverse through the relationship. From abstract, you can get a paper. From paper, you can get a title. From paper, you also get authors. For authors, you can find other papers. You can have some kind of further, like you can do a collaborative filtering. You can do like a community detection, right? Based on the search results to further enhance, to further re-rank the results to make it more relevant. So my point here is, even if embeddings or generated by large language model is very powerful, useful, it's not equivalent to relevance. We still need other methods, we still need other data to make our search results more relevant to the user, to the person who actually makes the search. By looking at a person's profile, right, person's classification level, person's search history, what other people are searching for or something similar, right, to make it more powerful. All right. Okay. In fact, the large language model, the LLM, can be used not just to do like Q&A over the knowledge graph. We can also use it to do an NER, a named entity resolution, entity linking, data cleansing, and also knowledge graph enrichment as part of the data pipeline. Once data from structured sources, unstructured sources, and even APIs, right, from any places, can be loaded into the knowledge graph in a central place. You can do search, you can do further data science, you can do enrichment, and to learn over the knowledge graph to produce better embeddings, right? Better embeddings. And at the front end, knowledge and related applications, the chatbot, right? Chatbot, search, recommendations, so on and so forth, can deploy it through the APIs, but also integrate with the large language model to help with understanding the question, generating the summary of the answers, and even do further things. Right? This makes the whole big pipeline with graph, large language model more powerful, more streamlined, and easy to deploy. You don't need to worry about, here's a document, I need a document store. Or here's a structured data table, I need to put somewhere else. Here's a vector, vector seems strange, I probably need to put some, like a vector DB. Here you only need one single place for all of them. All right, so in summary, I think a large language model, we have all experienced its power, and it's very huge potentials, amazing features, right, without doubt. But a large language model alone cannot solve the problem for most of the enterprises and the governments, because it can do hallucinations for the things it does not, because basically it's just a language model. The way it generates answers is based on the probability of the context provided before the question, right? To see what could be the most likely word or sentences following the question, following the previous text. It's a language model. And also, large language model cannot address the data security concern, right? Because it's trained over the public data. You don't know exactly what is there, unless you train your own model from scratch, right? And the lack of explainability. I think the researchers are still trying to figure out how this so-called emergent capability came to the large language model. All of a sudden, he can answer questions in a very good way. But till now, I think people are still trying to understand, figure out how to explain the results. Why these results, but not that results, right? But once we combine the large language model with the knowledge graph, domain-specific knowledge graph, enterprise-owned private data, and also has very well-defined structure, we can leverage the generalized knowledge, basically the language capability of human being, with domain-specific questions, answers, and context. We use the language processing capability or probabilities of LLMs based on factual knowledge, generate answers, and transform broadest responses to be the reliable and interpretable responses. So the two actually can work better together. That's a key point here. All right, so we believe from now on, vectors in the past, it's like a black box, it's a binary thing stored somewhere, no one cares. But now vectors become more and more important and relevant from data practitioners' point of view. And it's actually part of, because it's a language, it's knowledge of the AI and the machine learning models, right? It actually become another type of knowledge for organizations and the government, right? And it should be treated, stored, processed, queried together with structured, unstructured data to make to actually maximize the value of, remember, more than 70% of enterprise data is actually unstructured in the text, right? And a graph is probably for now, is the most ideal way of bringing all of them together. All right, that's my presentation. I think we have some time for Q&A, right?
All right, thank you, Joshua.
Thank you.